I think this is working. Uh, hmm. Oh, yeah, okay, there it goes. All right. Every time I work on this project, it just explodes in things to do and fix and deal with. Case in point, I've been trying to add the ecliptic to the star map. Sorry, my screen just flashed there. I was wondering why. Yeah, okay. I've been trying to add the ecliptic to the star map, and this highlighted some issues in my curve fitting function that I need to deal with. The other thing I noticed, you see, so one thing you'll notice is I have some of the star names turned on here. This was just to help me troubleshoot something. Just for fun, once I had the ecliptic in, I was looking at some other star maps like this one, and I was wondering, oh hey, um, where's certain constellations? And so for like Orion, like I can kind of see it. It looks a little different from what I expected, but I was like, yeah, whatever. But then I started looking for Gemini or Gemini, I don't know. And so I couldn't find Gemini no matter how hard I looked. It just and I thought it should be around here somewhere. And so I turn on the star names, and then I say, okay, Castor, Pollux, and I saw these other stars, and then I realized there's a bunch of stars missing in the Gemini constellation here that I'm generating. And I was like, why am I missing stars? So I went into this file here that I used to generate this map, and I'm using this IAU CSN, and this is my fixed version that I showed in the last recording. And anyway, long story short, I realized the issue. This file only has stars that have been specifically named, and more specifically, named in a way that the IAU recognizes. So there's a surprising amount of stars in here. There's like 5,000, well, okay, 500. But uh, yeah, there's tons of visible stars that aren't on this list and just don't have a specific name. For example, the one I was looking for the other day, this guy Tau Geminorum. So magnitude of 4.42, which is above the cutoff that I had, and it's just not in the list of named stars. These 5 stars here are not named. Um, these stars here are not named. This one's not named, and that results in most of the constellation being invisible. So um, that's the bigger problem that I need to deal with today. And by the way, there's issues with drawing this ecliptic. Let me try and show you. So first of all, here in my fit curve function, I had to add, where did I do that? I'm looking for where I added it. Yeah, I had to add this condition. What was happening was my reparameterization code was causing my parameter values to either stray out of the 0 to 1 range or have them go out of order. So I had to add this condition, and um, the other issue I'm having is that um, a lot of my segments aren't converging within the 32 iterations, which actually may be happening on the other curves in here, and I just don't know, but I think they are converging. And the other weird thing, which is a little bit hard to see, is that um, this ecliptic doesn't seem to be going all the way to the endpoints that I expect. So, yeah, something weird is going on here. I think it probably has something to do with this like edge case where there's this. Oh, hey, check this out. There's a little gap in the center here I didn't notice before. I don't know if that's visible at this screen grab quality. So these are just problems that I like observed while I was trying to add the ecliptic, and I got to fix them. So, uh, well, this is going to be more of like a housekeeping um, day than it will be doing development. So, first thing I'm going to do is go into this Gen Unkabut and just comment out the stars for one. And I'm just going to put a break here. Okay. The other thing I'm going to do is I'm just going to edit this segs to SVG function to just alternate the colors of the arcs just for now. Uh, uh, oh, wait, that's not how it works in. Oh, yeah, this is how it works in Lua. Yeah. Okay. Uh, oh. Oh, wait. This is just making a closed path. All right, okay, fine, whatever. Let's just not do that. And we'll just have to look at it in the like Chrome debug window. Wait, what? Nil? Wait, what did I do? Okay. So yeah, let's go in here, and we're just gonna turn on this guy. Oh, there's something else that I need, um, uh, which is I want to draw a box for the draw box so that I can confirm that this ecliptic is going all the way to the edges. So let's add that in. Uh, oh, not this. Thought since it was weird. So this x is going to be x off. This y is going to be y off. What did I call those variables? Draw x off and draw y off. And we're going to make this draw width and draw height. And let's make the stroke, I don't know, orange, just for visual interest. And yeah, so there's an issue here. The ecliptic really should be going all the way to the edge. Oh, I see. Yeah, it's going to be hard to troubleshoot because all right. Why is there no Z here? There should be a Z. All right, so this is where I want to start. I've never done this before, actually. I want to use Lua's debug features for this. I was just looking at it earlier. Uh, I started reading through this. It seems like something I can do. So debug set hook sets the given function as the debug hook, the string mask, and the number count describe when the hook will be called. The string mask may have any combination of the following characters with a given meaning. The hook is called every time Lua calls a function. The hook is called every time Lua returns from a function. The hook is called every time Lua enters a new line of code. All right, let's just try using the simple interactive one first. So let's put in a debug.debug. I don't know. Here, I guess. And just see what it looks like. Uh, that is not helpful. So we have 17 segments. All right, let's see what this getInfo function returns. Gets information about a specific function. To get a valid activation record, that was... yeah, okay. Push it onto the stack. Start. Get info positive function. For instance, to know in which line the function f was defined, you do that. Alright, whatever. Let's just fucking, you know. Oh. Alright. Okay, well, you know, whatever. Instead, let's see if I can single step. You know what? Let's just look it up. Whatever. I think what I need is set hook. All right, let's do that. Let's try that. Let's do right before we call. Let's do debug.setHook, debug.debug, and let's just try going on every line, maybe? Okay. So how do I print the locals? What is this? Oh, it's the index. So debug.getLocal 1 temporary, which is a function. What? uh, do I have access to dtab? I do. Okay, that's good. Let's do dtab of debug.getInfo 1. Source. Okay. Uh, okay. It's annoying that I have to type it every time because it doesn't have, you know. Oh, hey. Okay. We are now in common.lua. Segs to SVG. Current line 93. Hey, that's cool. Okay, okay, I think we're getting somewhere. So function, I'll just call this S step, I guess. And let's do, I don't know, equals debug.getInfo 3. And we will do I dot name at I dot short source. What is that short source? Oh, okay. Line number current line. Put a new line. And then we'll print the locals. So how do we know how many locals there are? Okay. I know, get local is what I wanted. Ah, okay, okay. It returns fail. So I guess what we want to do here is have a little helper. Actually, let's declare it in here. Uh, so debug dot get local 3 1 segments. Hey, That's cool. Calling this inside the debug prompt adds 1 to the stack, whatever. For now, let's just do this to see if this is even working. Debug dot get local of 4.1. And here we'll do debug.debug. And then here we will do step. And just as an interesting thing that I want to try here is if I do debug.setHookEmpty and continue, we should just continue. Okay, cool. Bad argument 2 to right, line 64. This is too long. And actually, we could print some characters, like those special color characters. But that's okay, we don't need to do that right now. Nil at Gen Occupant line 90. I guess we went up too many parts of the stack. I don't really understand. You know what? Okay, let's try this. Oh, Wait a minute. But I can't put cont in here. Well, whatever. So breakpoint at whatever. This doesn't work the way I want it to. So we're just not going to do that. Although we should do this. Well. Why is this so slow? Segments to SVG at line 112. Okay. So what happens if I just call this P function? Nil. Y. So this is in the S step function. So I need to go to 4? I don't understand this. Okay, let's try that. What? C minus 1. All right. Well, we can just guess and check until we get it, you know? I don't know why this is not working. Okay. 79. So we're in the S step function. But I don't know why I don't get a name. The debug prompt. That adds Who the hell knows how many that adds to the stack? Okay, what if I do dtab get debug.getInfo2 debug.getInfo3. So I think this is the debug function. Six.sv. I think I figured out why Replit is so slow. It's because my internet is goofing up for whatever reason today. Man, my computer is so broken. I should probably stop using it. Well, anyway. So now if I call this p function, all right, now we're getting somewhere. So what I want to do is val is equal to debug dot get local 5 idx. If not name, then break. And here we'll do print no local with name. If name, oh, whoops. I don't know. If name is equal to lname, then I guess just print val, right? And return. And otherwise, we'll do index equals index plus 1. That should work. All right. So now we can actually debug this. What I would really like is a way to go until a certain line. All right, I think. All right, let's do. Need a way to continue. Uh, hmm. Okay, okay. I think I know what to do. Um, let's do debugger state is equal to, I guess, run. And then we'll have a function breakpoint. And now here, instead of s step, I'm going to have a function oops, just a way to skip the skip dropping to the debugger inside the breakpoint call. Debug dot set hook s step l, and then yeah. And also we will do debugger state equals step. Else if debugger state is equal to until, then oh, you know what? A better way would be to have a table of breakpoints. And we're going to call this, I don't know, LDB for Lua Debugger. I'm sure this has been done before, by the way, but I'm having fun, so sue me. Else check if we hit one of the breakpoints in the breakpoint table. Check if this breakpoint is enabled. So breakpoint key is going to be equal to I dot short source I dot current line. And actually, so this is going to be, I think I need new index. Actually, no, I actually just need index tk. And this is going to be t of k is equal to enabled equals true. Num hit equals 1. Or no, 0? Yeah, 0. And commands is equal to nil. I'm not implementing commands today. And then here we're going to return t of k. So we're hitting a breakpoint and going in here, check if this breakpoint is enabled. Break info is equal to debugger breakpoints of the key. If break info dot enabled, then we will do okay, this is a neat little thing we can do. Then debugger state is equal to step. And actually, we are going to do this. Function B name. This is going to be set breakpoint on current line if name empty, or set breakpoint on named function. Okay, one more thing I need. Temp equals 0. So now here what we're going to do is if it is enabled, then we will do that. And also, if breakinfo.temp, then breakinfo.enabled equals false. And we're also going to increment the number of hits because why not? Well, we're not using it right now, so I'll just leave it as a to-do. All right, I gotta get up for a second. Oh man, someone started watching just as I was gonna get up, but I need to go for a second. All right. Where was I? Oh yeah. Okay. So the debug state is in a breakpoint check if it's enabled. If it's enabled, we go to step. And if it's a temporary breakpoint, okay. So set in a breakpoint. We will do debugger breakpoints of the given key. So if not name or length name is 0, then set breakpoint on current line. And actually, if it's a temporary breakpoint, ooh, I could make this work the same way as GDB, where the breakpoint number and you know what? Just let's not deal with that. I don't want to delete it. We'll just disable it. Oh. You know what? We're just gonna print not implemented. Sad face. Okay, and we disable it. Oh yeah, the last thing, the whole reason I went through all this trouble until, ooh, okay, it's gonna be you in that case. Line no. We're going to do oh. Yeah. Yeah, okay. I guess what we'll do is hmm. uh, well, you know what? It is what it is. I don't want to overcomplicate things for now. I mean, GDB would do the right thing if you type in a line that doesn't actually have runnable source code on it. It will automatically put a temporary breakpoint on the next line that has runnable source code on it, but we're just not going to do that. So local temporary breakpoint key is going to be the same I.short source, but instead we're going to use the given line number. We are going to do debugger breakpoints of tbreak key dot enabled equals true, and we're going to set temporary equals true. Think that'll just work? Probably won't. Error loading, then expected near local. I'm gonna need to debug my debugger. Okay, so segs to SVG on line 173. So let's do a step, which you do by typing cont, which, you know, is less than ideal, but that's okay. So now we can print closed and see that it's true. So now I want to try going to until line 192. This is unlikely to work. Oh, you gotta do cont. Yeah, okay. So So then, yeah, when I run the until function, I need to do debugger state is equal to run. You know what? So this will still be break. Check if the current line is in the breakpoints table. We do this as a separate case so that we don't add breakpoints on every line. Local break info is equal to raw get of debugger breakpoints and breakpoint key if break info and well, you know what? That's all I need. Then we will do debugger state equals break. All right. I always forget this. Okay. So 182, 183. It would be cool if I actually read in the file and, you know, printed it. I wonder if there's a way to do that actually. Oh, hey, look at that. I actually can implement the proper until logic. Well, we can add debugger features as we need them. For now, oh, did I remember to change the state inside the until function? Yes, I did. Okay. True. Okay, so now let's do until 192. See if that works. Single step. Oh, that's interesting. I might actually leave that on for now. But anyway, we're on line 192. So let's print connected. It's just true. Oh, yeah, actually. I need to make a debug info function. Now let's do until, okay, yeah, well, whatever, it's okay. Yeah, let's actually do 201. All right, that's cool. Now let's print connected. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, why is this false? How are we detecting connectedness? Here we use equality testing for floats because we happen to know that our curve fit function is exactly equal points for connected segments. I think I see the problem. Or do I? Ooh, does this work? Line 97. Oh, yeah, okay. Alright, hold on. Let's do a little bit of, Ooh, we are also going to return val. I guess. So I guess we'll do the same. Oh. So let's do s equals segs. It's kind of clumsy, but it works. You know what? Okay. So 44.85 to 44.77, 44.77 to 44.39, and so on. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 87.8 to 87.73, 87.73. Or maybe it's this one. Oh, wait, yeah. So 528 to 427, but then 420. Oh, I see the issue. Oh, man. I see the issue. Let's just do this to let it finish. The issue is really dumb. We're starting here and going here, so it's obviously not connected. Oh, but wait a minute. Okay. So let's go back to that spot. So until line 202. Okay. Clumsy, but it works. So we start at 44.854, blah, blah, blah. We end at 44.854, 27.427, 27.427, but the curve should be closed. So why are we not printing? Okay, what's the start index? 9. Why is the start index 9? And why is 9 not connected? Connected of I is equal to whether the first is equal to the last of the one before. So connected of 9 is equal to whether the first is equal to the last of the one before. Okay, so what's going on here is we're moving connected to that point. We're moving the start index to that point. And so we're drawing from the middle all the way to the left-hand side. Then we're drawing from the right to the middle. And we want a Z at the end for the middle to connect. So how do we deal with that? So yeah, our start index is 9. So we're starting on the right-hand side. Then we're going to the middle. Wait, I don't understand. We're starting on the right-hand side. Then we're going to the middle. So 46 point whatever. All right, I think we just need to start single stepping. One really important thing. Actually, are we in single step mode when we hit an until? Hey, perfect. So line 203. Line 204. So I is 9. Yeah, it's annoying that I can't type expressions in here. But there's really not much that I can do. Whatever. So 9 plus 17 minus 1 is 25. And that is greater than 17. And so index is going to be 25 minus 17, which should be an 8, right? So we are sweeping all the segments. There's no off by one error in this logic. So if I is equal to the start index, or it's not connected, then we have a move to. Okay, is there a move to in the middle? Oh, there is. Wait, what? Ah, I see the problem. Index. Okay, that should fix that. Wow. Wow. By the way, one more thing that I want to do here is function d. We will do okay. So this won't exist, right? Yeah. Um, Whatever. I can just do this, and I can do this. All right. So now if we run it, hey, that is progress. So here we have it all connected, and we correctly don't have a Z because actually I forgot I had that special case in. Okay, so now the next question is why aren't we getting all the way to the draw width? I wonder if it's just a case of um, my ecliptic function. So uh, right. Oh wait, that does go all the way to 3. Oh man, what is going on here? You know, I'll bet you this is because my sampling function. Yeah, damn. Damn. I know exactly why this is happening. It's something I was worried about. Um, so the sampling function is always trying to hard to explain. Um, all right, let's just try a really quick little hack in the sampling function. Let me also try to explain what I think the issue is. Where's my sample function? Here it is. Oh wait, no. I want this sample max spacing function, which is in here somewhere. So here what's happening is, all right, let's just talk through it briefly. First, I make sure that the parameters are in increasing order. I calculate the values of the function at the endpoints. I have this little helper variable for the squared distance, the maximum squared distance. If the user did not provide a distance function, then I provide a default, which is just the Euclidean norm. And then I have a list of samples that are currently not in order, but then we sort them before we return at some point. And this is the function. So what we do is we find the midpoint. So, okay, PT0 and PT1 are the points at the, are just 2 points. And we're asking the question, do we need to sample these more finely? So the midpoint of the parameter between these two is the midpoint of the first element of these 2 point objects. This is not nice code. I wrote this really quickly one day. But anyway, then we find the function value at the midpoint, and then we make a point object for the midpoint and add it in. We're always going to add it because, I mean, hey, we bothered to sample the function, so we're going to keep it. And then we measure the distance between, so element 2, I really should have just made this a struct, but anyway, element 2 is the function value. So we ask what is the distance between the left point and the middle point, and what is the distance from the middle point to the right point. If these distances are too big, then we recursively call this recurve function, which will add in the midpoint and continue to, you know, sample it at midpoints until we no longer recur because the distances from the midpoints to the endpoints are not too big. Okay, now, how do we know when to stop? Well, okay, if we meet tolerance, then we can stop. Okay, that's fine. But if we don't meet tolerance, and we are approaching a discontinuity, and this is what is, I think, is happening here. So what's happening here is that the function goes, it starts in the middle. Is that right? Does it start in the middle? Can't remember all of a sudden. But anyway, let's say it starts in the middle and goes to the left. And then there's a discontinuity where it comes in from the left and goes to the middle, right? And what's happening here is no matter how finely you sample between, say, this point and that point, this discontinuity will always be there, right? You can't get over that by sampling at finer intervals. So what I do is I say, okay, if you find the midpoint and it still didn't make things better, strike one. If you find right? So we found the midpoint, and now we're going to recursively sample between these 2 points. Okay, so now we find the midpoint and sample between those two, and we didn't converge, strike 2, and we keep doing that. And I have it set up for 5 strikes right now, but here's the thing. 5 strikes means that we might not get all the way to the discontinuity, right? And there's really no nice way to deal with this that I can think of other than um, increase the number of strikes, you know. But we can keep finding the midpoint until the midpoint gets too close to the previous sample. We can do something like that. You know what? Let's do that. I mean, this is all heuristic anyway, so here the first thing I'm going to do just to actually check that this is the issue is I'm going to crank up the maximum strikes and see if that pulls the endpoints closer. So let's just make it like 50 or something. And if it pulls the endpoints closer to the end, then that means that yes, this is the problem, and I can solve it by adding some extra logic here, where instead of if we hit the max number of strikes quitting, we'll do something different. I'll have to think about what that something different is, but let's just see if this is even true. Yeah, that's exactly the problem. But, you know, maybe I can just leave this. uh, all right, I have an idea. I was about to say something like, well, you know what? 30 ought to be enough for anyone, right? It's not expensive to have extra strikes. It looks fine. "30 strikes ought to be enough for anyone." You know what? Okay, that solves that problem. And now, for the final problem, which may have been fixed by either this or the fix earlier for using index inside the segs to SVG function. Where I don't need a breakpoint there anymore. I'm just going to get rid of it. And actually, you know, for the sake of housekeeping, let me add in ldb.lua. I can carry this around to other projects, so it is worth separating this out. Let's go in here, grab all this. Put it in here, and now we can make this a proper require, which is nice. And let's just see that that works before I stop. That's curious. it not save or something? Oh yeah. Oh yeah. Perfect. All right. Great. So actually, let's just go ahead and add that in right now. Do I want to discard? Oh, I see. I just pick the ones I want to stage. One staged file. Add nifty debugger. So we'll do that, and then we'll separately fix out of bounds bug in segs to SVG. Is there a way to review the changes? I guess I could do. What the heck just happened? All right, what's going on here? Oh, comment's a new file. Ah. All right, in that case, I guess I'm just gonna go ahead and do, I'm gonna have to do it all as one commit because I didn't do the split it into a new file separately. So bam, bam, and bam, and bam. Oops. File reorganization and bug fixes, and why the heck not? Let's put to do in there as well. Bugs fixed. Out of bounds index in segs to SVG. Causing disconnected curves. Safety check in fit segments to prevent bad reparameterizations. Crank up max strikes in sample max spacing to approach discontinuities a bit closer. And I guess I'll also, for the sake of posterity, reorganizations, move common functions to common.lua. That's it actually, so I won't bother to put it. It's pretty obvious from the commit. Go. And go. And over here in the git ignore, I also want to not grab this. Okay, and then here, I can go in here and do git ignore Cali drop temp files. No idea what they are, but I don't want to see them, so do that, and then do that. Okay, good. The last bug, which I haven't actually mentioned yet, is in here. I noticed that if I did 0 to 360, it had bad results, but I actually thought the discontinuity was on the first point, but it actually wasn't. So now if I do, yeah, this didn't work last time. Oh, it's fine. Okay. It's just fine. All right, well, good for us. All right, well. Well. Now we need to do this. Oh, and by the way, I guess I started adding the ecliptic. I do need to add the true sun date markers. So I have the curve, but I need the markers. Yeah, I need to deal with this. And, oh man, oh yeah. Okay, one thing at a time. If I go here into old, I have an old file that I was using at some point to read the Berkeley Star catalog. I can repurpose some of this code. Let's just go in and see what it shows us. Yeah. So, you know, just a bunch of stuff in here. Oh, I guess I only printed the first 30. And it looks like they're sorted by increasing magnitude, so this is Sirius. I don't know which one this is. I just know that Sirius is the brightest. Okay. So this is just a big ugly file. But thankfully it comes with a README to explain what any of it means. Which let's take a look at. I forgot. Shoot. I forgot to change the font size before streaming. It's really hard to read this font unless it's bigger. Damn. Well, too late. All right, so byte-by-byte description of the file. So there's a star number. What I really want to do is get the constellations at some point. Oh man. Ay, ay, ay. And why is there a question mark here? Uh, oh, here we go. These fields are all blanks for stars removed from the Bright Star catalog. Right. Well, that makes things more annoying, but it's fine. Now, what's really annoying here is, oh, okay, they do have J2000. Okay. The reason that's important is because I need to be consistent if I happen to use data from different sources. And by the way, J2000 is just easier for me to deal with and understand. So, you know. So hours, minutes, seconds. And this is a floating point number, or a fixed point number, I mean. I did I did encode all this logic in that script there, so I don't have to completely understand this. I just want to know what's in here. I want to know if they have information about what constellation it's in. They don't even have the name either. Like, they don't have the common name is what I mean. All right. So what we need to do is go into here, and instead of this, as much as I prefer this file, for some reason I just like this file better, but as much as I prefer it, I'm going to use the other one. So let's just do it. I need these two files. I need this logic. I don't need the little printer here. Then I go into here, and man, it's really hard to code with the font size so big, but it has to be this big to be visible, so it is what it is. So instead of this, we are going to have this. And let's add a little comment here. Read in star data. Hours, minutes, seconds, convert it to degrees because degrees is my preference. And then we can sort it. So we have magnitude, right ascension, declination. And then here we can go close the file. I don't know, SVG prologue. Sake, add an outline for the safe drawing area. Now we draw the ecliptic, blah, blah, blah. And its magnitude, and then finally here, magnitude, right ascension, declination, name. Well, too bad, we don't have a name. So, yeah, get wrecked. And here we definitely we don't want anything greater than, what magnitude is visible? Visible, or star magnitude visible to naked eye. Dark rural areas. Four. Let's leave it at 6.5. I don't really know where I got this number from, but let's just leave it there. Okay. This is probably going to be very busy. Okay. Okay. So something has gone wrong here. A nil value. Oh. Yeah. Okay. Oh, dang. Ay, ay, ay. Oh, man. Uh, Oh, never mind. At least I found the problem. That's something I'll have to deal with. Is why can we not single step from the top level? But we'll deal with that some other time. Okay, so this is probably going to be very busy. Oh yeah, oh my god. Okay. That's cool, you can see the Milky Way. Alright, let's take a little peek here and see if we can actually see Gemini. Oh my goodness, that's slow. Oh yeah, yeah. Okay, okay. Yeah, it's very, very, very hard to see because there's so much noise in here. Okay, one thing I need to do is deal. Okay, so um, uh, and also let's turn it down just a little. Um, okay, that turned it down quite a bit, but can we see Gemini? Yeah, it's a little hard to see, but here's the two heads, the arms, the legs, you know, nice little stick figure. Yeah. What I don't like is how the faint stars are still big enough that they're confusing me with the brighter ones, but yeah, I can see Gemini. Just leave alone the Gemini. Oh yeah, okay, here's the Orion's hands that are on the ecliptic. What else can we see? So Gemini or Gemini, or I don't know how people say it, is over here. So, gosh, I don't know my zodiac constellations at all. I wonder if I can find Pisces. Uh, Pisces is just a big, like, swoosh, basically. Uh, it might be this, or, and then Aries is just a stupid little check mark. I think this is Aries actually, right here. And here's Cassiopeia. Here's Polaris. Here's the Big Dipper. And can we see the Little Dipper in here? It might be hard to see because it's so skewed up here at the top, but uh, yeah, I don't know. But here, what we can do is, hold on. Um, One of these days, I'm actually going to want to sit down and learn the Chinese. They're not called constellations. I forget what they're called. Yeah. the star like clusters. Like they're not constellations. Ooh, that doesn't help actually. So yeah, Cassiopeia, and then Ursa Minor, Ursa Major. Oh, it's all the way over there, huh? So, all right, hold on. Little Dipper. Okay, we've got a pretty bright star here, and the Big Dipper is somewhere over here. Can I see this also? Polaris. Maybe it's this? Like this right here, maybe? Oh yeah, there's kind of like, you know, near the handle there's a bunch of extra guff. And along the handle there's like two stars together, so uh, hmm. I'm still having trouble seeing it, if I'm being honest. But I do want to draw in the constellations. All right, let's see which other ones we can find. I'm kind of having fun with this. Um, there are a list of constellations that I can just click on. Ah. Okay, so Aries is kind of like here, and oh, Pisces. I see. Pisces is cut by my right ascension of 0. Um, it's also rather hard to see. Maybe it's this coming up like that. I don't know. But Aries is. What did I think it was a second ago? Hmm. Uh, apparently Aries is like here, which is like here roughly. Yeah, it's not the most interesting constellation, to be honest. Just a bunch of junk in the middle of nowhere. Oh, the pizza slice. I wonder if I can find the pizza slice. Uh, uh, hmm. So the pizza slice has like 3 stars nearby to each other. Maybe 2 depending on what magnitude I picked as my cutoff. I think I did 4.5 as my cutoff. All right, hold on. Let's take a look at triangulum. I think I've told this story before, but we were out camping, and we were looking at the stars, which were fantastic. And um, I was asked my buddy. I said, "What's your favorite constellation?" And he said, "The pizza slice." And he was just making a joke. We're like, ha ha ha. And we point at just some arbitrary stars that formed a triangle. I don't know if it was these or not. And then I, later on found out that there is actually basically a pizza slice constellation. So anyway, what are the stars involved in it? Uh, That's interesting. They all have planets. How do I get the list of stars in it? Okay, 3. Second brightest star, 3.41. Magnitude 4. So these should all be visible on my guy. So here's Gemini. Just leave alone the Gemini. Is this the pizza slice? Right here? Could that be it? No, it's way too close to the ecliptic. I'm still looking for Aries. Oh, this has got to be it, right? Is this the pizza slice? Could be. I should really put in a grid for the right ascension. That would kind of settle this, but... Alright, I've become bored of looking for constellations now. Oh yeah, here's a Southern Cross. Maybe I haven't become bored of it. No, what I'm trying to think about now is how to make this look better, because it looks so bad. I think it's because my circles are too big. I think that's the issue here. Now, the problem here, and we can check this actually if we go on Pinocchio, but the problem is I think if I make the circles too small, Pinocchio's going to choke on it. What I'm hoping is if I upload this SVG to Pinocchio and I say, hey, can you print this, that they'll have like an automatic warning that says, hey, you might want to make your circles bigger. So let's do that actually. Okay. Oh, wait, why did it take me here? Quote. Where did I save those? Ugh, where did I save anything? Oh, here we go. Just get out of here. I can't see. What? What is this? Just get out of here. Just no, 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 no. How do I close this? Oh, here we go. Okay. Now, here for area engraving. Area and line engraving. Guess this will be cutting. This is ignore. And this is going to be a line engraving. 91.9 by 53.8. Yes, that is right. Just get out of here. Oh my god. Okay. Yes. And then let's actually, I am using acrylic for this, not that it matters, because I'm not going to buy it right now. It's not, the design's not finished. But I'm hoping they're going to be like, they're going to tell me if my design is too small. Hey, wait a minute. What am I doing? I just realized. Oh my god, stupid chat, get out of here. I just realized I'm not printing this on acrylic, I'm printing this on paper. So actually what I care about is the minimum feature size for like Vistaprint. Stop. Oh my god. Okay. Yeah. So I noticed that they have marked out some edges here. Ooh, that's way more expensive. Yeah, okay. Well, anyway, instead what I need to know is what's the minimum feature size for something like Vistaprint or like, I don't know, Control N, printer minimum pitch or feature size or something. Hmm. No, no, no. I want regular printing. Just like, I don't know, laser printers. Like, no. Just like a regular printer. Ugh. It's hard to get an answer to this sort of thing. Alright, let's go to Vistaprint and see if they spec it out. Just whatever. Just whatever. Specs. No specs. Vistaprint minimum feature size. Okay, minimum line width. Dots per inch. Aim for Vistaprint products, aim for at least 300 dots per inch. We recommend a minimum of 300 dots per inch on every image printed, meaning that the background photograph on an 8.5 by 11 flyer would need to be so-and-so pixels. That's it, that's all they say. Okay. It's hard to get an answer. Typical printer DPI. I mean, come on. An inkjet printer sprays ink through tiny nozzles, typically capable of somewhere between 300 to 720 DPI. A laser printer applies toner through blah blah blah, maybe in the range of 600 to 2,400. Okay, so finally we have an answer. So in here, we will do minimum dot size on a printer I'm using. So printer DPI, let's set it to be, it's got to be more than 400. The average photographer, 1200 DPI is excellent. All right, what about Staples printing DPI? $600. Just, oh my god. All right, just. Let's just see what printers they're selling and try to get a bead on. Geez, I don't even know what kind of printer they'd be using. Does Vistaprint use inkjet or laser? All right, let's see what they say here. If they, I mean, you can't use a laser printer on plastic, right? Okay, maybe I can like infer it by looking at this picture. Ugh. What is it gonna take to just know what the DPI is? Okay, it looks like we can achieve, like, all right, hold on. Let's put this in paint so I can actually count the pixels. The things you gotta do to get an answer to a simple question, oh my god. I don't think this image is going to be the one that will answer my question. Let me find another one from the site. Okay, this might be a little easier to work with. So let's just take a look at the tittle on the eye. So this is, let's say it's 3 pixels across, for example. Now the resolution appears to be a lot better than that. This is just a picture of a picture, so I'm just guessing. But let's say that it's 3 pixels across. So how wide is the whole thing? We go from 342 in the X to roughly 751 in X. So, or let's say 752, so that's about 400 pixels, 410 pixels. So, wait, 3 times, oh no, 3 divided by 410 times, how wide are these guys? Oh yeah, I'm not sharing the right window. What the heck is going on here with OBS? Okay. So, times 53.62 millimeters is whatever this number is. So this is in millimeters. Let's just do this in inches for a second. Oh. So this is about 15 mils. And if I do 1 divided by this number to get the dots per inch, and this is a very, okay, well, it's going to be more than 65 dots per inch. Let's put it at 300. Let's just put it at 300. So dot size, so this is dpi, is going to be equal to printer dpi times for, I know, 1 divided by printer dpi to get inches per dot times 25.4. This is in millimeters. So 25.4 divided by 300 is that number. Okay. So finally, you can go in here and go in there and go in here. Remap dot size times magnitude to range 1 to 2. Let's see what that gives us. All right, is this any better? Hardly. They all look like they're the same size. All right. Still can't find the pizza slice. Is this the pizza slice? I don't know. Maybe it's this. I just can't tell. All right, hold on. I'm getting distracted here. What was I doing? Oh, I fixed this. Yeah, this is done. Okay. I do need to add tick marks on the ecliptic. Let's organize this to have all the ankabut together, and then I can also do the ecliptic, or the Lowat later. I really would like to have constellation line art. That is not easy. So the time of day line, where am I going to put that? Yeah, that's going to be on the Lowat. Yeah, honestly, the Lowat doesn't have much to it. I've already done this. Actually, what then I should do? Uh, and I'm also going to regenerate this now that I've fixed that discontinuity logic, because it might, I don't know, do something. Well, it didn't really do anything, but that's okay. So this is my half-finished time of day scale. I'll deal with that at some point. Then here, I need to add tick marks to the ecliptic. I need to add the date line. I need to add in constellation line art. It would be nice to name some of the brighter stars, and it would be nice getting this looking nicer as well, because like I say, just, I don't know, it looks bad. It's just hard to see constellations. The dots just don't feel nice. Like, I don't know. I don't know. I don't know how to fix this. But anyway, we'll cross that bridge. Yeah, I don't know if I want to do this manually. I think for this, we should be able to do that in code. And whatever, just get rid of that. There's actually a name for, I've recently saw it somewhere. There's a name for putting a table of different cities on a astrolabe. I just can't remember what it is right now. All right, let's do this. Okay, so we have a design decision to make here. Are we going to include the equation of the center? And the answer is why not? I guess it's not a big deal. We can just do it, right? So, yeah. So, yeah. Let's do it. And let's also try to organize this code a little. Oops. All right, let's just get this all checked in for the moment. What have I done here? So I added in the BSC5. What did I do in here? Just random stuff, doesn't matter. And you know what, I won't add this to the commit. What did I do in here? I just added the bounding box. Yeah, I won't bother to commit that. And I'll save the to-do. Okay. Close this. Close this. Oops. Whoops. Use Berkeley star catalog, which I really only need this for it, and I may as well save the to-dos, just, you know. How big are these files actually? 1.7 megs. Well, whatever. I probably shouldn't have checked that into Git, but yeah, it is what it is. So why does it have an A here? Oh, shoot. I needed to add that to the last one. You know what? Am I going to regret this? I'm probably going to regret this. Yeah, okay. Okay. This is all looking like I expect. Yeah, Okay. So now that that's checked in, I can feel this is something that I have to do at work pretty often. Is if I'm about to make a change to the code where um, I have some, I don't know, inertia to starting it because it'll be kind of difficult or things will be broken before I get it working. Um, I find that checking in to Git before I start kind of helps me get over that mental barrier. So um, now add tick markers on the ecliptic uh, for dates. Okay, now one thing I need to figure out, or not so much figure out, is decide on, is how we're going to deal with the whole leap year thing. Because the sun's position along the ecliptic is not exactly the same from one year to the next. Um, so, like, let's say that I labeled, you know, uh, this position as June 20th or something like that. Then on the next year, on June 20th, the sun will have ever so slightly moved. And that is because of leap years. The length of a year is actually 365.25 days. And so we shift by a quarter day every year. But, this is why I'm kind of going like, am I going to bother with the equation of the center? Because I'm only putting one set of year markers on the ecliptic, all right? I'm not putting year markers for whether you're in the first, second, third, or fourth year of a leap cycle. That would just be way too busy, and it just wouldn't. No one would care. Um, so if I'm not going to bother with that, is it worth bothering with the equation of the center? And the answer to that is like maybe. I mean, it's not hard to do, so we may as well. Which means that we're going to have to pull up that article again. So Alejandro Jenkins, the sun's position in the sky. How big is this PDF? I almost want to save it in the Git repo just because of how useful it is. 5 megs. I don't know. Okay, what's the rule of thumb for Git file sizes? Yeah, anything greater than half a meg is considered large, which, yeah. I wonder if there's a way that you can compress PDF or something. Oh, I have seen people save PDFs inside of Git repos. Like, not a big deal, and it is nice to have everything in one place, you know. But if it's gonna be 5 megs, that's like a little excessive. So if I can compress it down to like 1 meg, I think that's fine. Uh, nah, forget it. Why is it so big? I mean, like, these images are probably all vector graphics. It's just text. Oh, there's a image of New York. Yeah. Whatever. Don't want it. Whatever. Let's just push it in. Who cares, right? So. Okay, for some purposes, it may be acceptable to approximate the angles increasing linearly and completing a full revolution in 1 year. As do the authors of. Okay, what is 6? Oh, yeah, I know. A precise expression can be obtained from Kepler's first and second laws, which says the Earth moves along an ellipse, with the Sun out of focus, while the line segment from the Sun to the Earth sweeps out equal areas in equal times. The angles obtended by the line from the Sun to the Earth with respect to the major axis of the elliptical orbit is known to astronomers as the true anomaly and is usually represented by the letter V. Finding V as a function of time is no exact analytic solution, but an expansion can be obtained that converges rapidly for small orbital eccentricity E, known as the equation of the center. Yes. Using the current astronomical data for the parameters blah blah blah, we can write the equation of the center for the Earth as blah and blah. Now this is all in radians. So, okay. If it would be convenient to measure the angle from the first equinox of the year, therefore we let the angular displacement between the perihelion and the first equinox. So this is just someone measured it. I don't know how they measured it, but they did. Yeah, so this is in radians. Oh, what's this? Oh no, hold on. The value 2 pi over m1 is slightly greater than 1 calendar year because of the slow precessions of the equinoxes and the perihelion. Yeah, sure. I mean, less than 2 degrees at any time of year. t=0 corresponds to January 1st UTC. That's not what I want, though. Or is it? I mean, yeah, actually. Yeah. Although this number here, 0.017202, that is 2 pi divided by the length of the year that they're using. So if I want the length of the year they're using to do 2 pi divided by this. Okay, so they're using 365.25, which is fine. I guess. Yeah. All right, let's just implement it. I would like to understand it in more detail. Function true anomaly of D. This is a completely stolen function from Alejandro Jenkins's the sun's position in the sky. That is a really great article. I recommend reading it. So, wait. Anyway, D is the time in days past January 1st, 2013 UTC. Went too far. And T time in 24-hour days past January 1st, 2013 midnight UTC. I think it's fine. Local M is going to be so this is going to be in radians. Blah. And then local V, local theta E, just to match my notation. Although I think he's using, or I should say they're using phi. I'm trying to get used to that. So, plus M plus times math dot sine of M. I think it's all in one line, I think. Plus 0.003 times math dot sine of 2m. You know what? Let's split it over 2 lines. Or even just one is fine. This is in radians. And then we're going to return math.deg of theta e. Returns angle in degrees around the ecliptic measured from the March equinox. Or at least I think that's what it does. Okay, so now we're going to do local, or I guess I don't need that. So months is going to, let's just start by printing out the months using, I don't know, is going to be Jan, Feb, March, April, oops, May, June, July, August, September, October, November. Oh, I just realized something. Yeah. Yeah. I'm doing that trick on my knuckles. You can't see me, but you know how you can use your knuckles to find the number of days in each month? Anyway, look it up. January, February, March, April, May, June. July. August. September. Do you remember? October. November. And December. D is equal to 0. For in I pairs months due local tick pause. Okay, so local. The tick pause is going to be ecliptic of true anomaly. D is equal to D plus M1. And now we need to actually draw it. So we're going to do f right string format. What should these tick marks be? Let's just do vertical lines for the time being. Line x equals percent f y equals percent f. Stroke equals green. Stroke width equals percent f. Is there a little SVG vertical line? Sometimes there's like nice little. All right, SVG line element. Let's look at the docs. Now, you know what? And we are going to use take pause 1, take pause 2, and laser curve, because that's what we're using for everything. SVG line cap, is that what it's called? Stroke line cap. So we're going to do stroke line cap equals round, because I prefer that. So this means that the laser curve comes first. And this, I'm just going to use an arbitrary, I don't know, not 0.1 millimeters. Why not? And let's also do f right string dot format text. And now we need to find the text element. Oh, like that. Okay. X equals percent f. Y equals percent f. Font size is equal to percent f. We're going to do percent s. And what else do we have here? font size. Okay. Yeah, oh yeah, I already got the font size. And it would be nice if I could center it. SVG centered text. There's got to be a way. Text anchor. Yeah. I want this. So we're going to do tick pause 1, tick pause 2 plus 0.1 font size. I don't know. 0.5? I have no idea. And the text is going to be M1. This is M2. Go. So that didn't work. Why? Oops. Oh wait, it did work. Except the ones are dead wrong, which is funny. January is not here. And yeah. That's curious. I mean, at least it's on the line, so that's nice. Something's wrong. What is this plus 180? Oh. I see the problem. Wait, no, I don't. What happens if I just get rid of that? Okay. Now we have a different problem. And March is still not in the right. Well, it might be right. April, May, June, July. It's just like upside down, which is weird. And also, it's connecting this. Why is that? Oh, it's got a Z on it. Yeah, it's because I said it was connected. So this is where I'm gonna go ahead and do my weird little trick there. You know. So we still have some problems here. Uh, oh. Okay. Um, so we're kind of getting closer, maybe. I don't know. What the hell's going on here? Everything's upside down for the ecliptic. This looks terrible, but you know. Why is my ecliptic upside down? So theta is that. And I see I did this in my notebook, so I can't show you the math, but I'm just gonna look at it and see if I can figure out what I did wrong. It might just be that I have the wrong sign on the tilt. In fact, that's almost certainly what it is. If I just do this, I bet you it'll fix it. But I would like to understand why I have the wrong sign. But then again, who cares? You know. Okay, May, June, July, August, September. And just as a way to check it, winter solstice dates, December 21st. That seems about right, 2/3 of the way. And summer solstice date, June 20th. Yeah, seems about right, 2/3 of the way. And spring equinox date, March 19th. Yeah, it seems right, you know. Right? Okay, so we got some work to do to make this look better, but I'm gonna go ahead and mark this off on the to-do, or at the very least I'll put a half done. This goal doesn't include making it look pretty, so we can work on that later. I guess it would be nice to add tick marks for the days in between, and then I'll call this completely done. These tick marks are too big. I don't know why. I think here. I need this. And let's make this a little bit smaller. And also local, whatever, we can just copy paste, it's fine. I'll do for, I don't know, D2 is equal to D plus 1 up to M uh, 2 minus 1. If, so let's do local tick height is equal to D mod 10 equals 0 and not 0.6 or not 0.3. Yeah, you know. Or we could do D mod 5. And then we'll do bam, bam. And here we'll do minus height. And we can even do if at D2 mod 10 is 0, then and here we will do toString D2 30th. Okay, well, you know, if D2 is equal to 10 or D2 is equal to 20, you know. Then here we'll do minus 0.8 or something, and we can make the font size a little smaller. I mean, this is all totally arbitrary. We're just going to fiddle with it until I'm satisfied. Why didn't that work? Did it not save? D. Oh. D plus D2. Yeah. Oh, that's very busy. Well, it's kind of cool. Well, you know what? We can make it look better later. I'm going to call this to-do item finished. Okay. I probably need that. I'm just going to go ahead and add it in. Add ecliptic tick marks, but needs work to look good. Better. Okay. Now for something really difficult. How on earth are we going to get constellations? Uh, Well, before we do the constellations, I have to do this, and this is kind of a. I'm just checking to see if yeah. This is kind of a. I'm gonna take it. It kind of goes hand in hand with this half finished thing here I have on the Lawat for the time of day. They have to line up, and I think what I've done here on the Lawat is a little ugly. How long have I been working on this? Almost 4 hours. All right. I think I will stop for now and carry on. I might do this later today. But before I stop, let's think about how we're going to do this. I think uh, so this time of day line needs to be shifted for your latitude. Doesn't need to, but it will lead to something nicer looking. Um, so, uh, okay, let me explain in more detail here. So, it's actually nice now to have these images generated. It makes it easier to explain things. So, on March 20th or 19th, it seems, one of these days, we have an equinox. And we define the mean sun and the true sun to be at the same meridian at the equinox. And let's just say at noon on the equinox, noon UTC, or And so, is that right? I think that's right. I think that's how we define it. And so when you align your noon line, the south, excuse me, with, um, this equinox line right here, then this time scale line here that I have in the center for 12 noon will be directly underneath it here. And so the second dateline that I haven't added yet should have the exact same date as the ecliptic marking directly above it, but only right here. And then the rest of them are going to be linearly spaced for the rest of the year. So this means that sometimes they will lag behind the ecliptic, and then they'll catch up and then race ahead, and lag behind, catch up and race ahead, and so on throughout the year. So yeah, that's not so bad actually. So yeah, this line here and its tick marks will line up with this line here and its tick marks. Let me go into a little bit more detail because I did figure this out the other day and I found it kind of interesting. This scale here makes one complete revolution, or in other words, it moves through the entire length of the 360 degrees of, um, you know, motion. I don't really know how to explain this. It does that once per sidereal day. Now, if our clocks measured sidereal time instead of civil time, then, um, well, uh, whatever whatever part of the timeline, so this here's the sidereal time scale, whatever part of the sidereal time scale aligned with the left edge of the Ankabut would tell you the sidereal time, okay? But what happens is throughout the year, um, there is a slight difference between man, how do I explain this? It's not a slight difference, but it drifts slightly every day. There is a difference between the sidereal time and the civil time, and that drift occurs linearly. And so, when instead of aligning against the left edge, what you're going to do is add an offset proportional to the drift that's accumulated over the course of the year. And so that's what the second date line is doing. It's saying, you know, when you're this many days through the year, like when it's June 18th or something, you need to add this much correction to the sidereal time to get the civil time. Hopefully that makes sense. I'll draw it out next time I work on this, and maybe it'll be clear. I actually did write out all that logic here. You know what, let's just go through it, because I don't feel like stopping quite yet, but I'm just too tired, or too, like, zoned. A sidereal day is 23 hours 56 minutes. A standard day is 24 hours. Suppose that in the sky there were two giant pointers, and here by pointer I'm imagining a line of constant azimuth ranging from minus 90 degrees to 90 degrees in elevation above the horizon. This would trace half of a great circle along the celestial sphere. So one of these pointers always points to some distant star, say Deneb, doesn't matter, and one that points straight north geographically every day at 12 noon, so this is standard time. And the second pointer always takes exactly 24 hours to make one rotation, so that's standard time. These two pointers drift apart at a rate of this expression per standard day. The 4 in the numerator is the difference between the sidereal day and the standard day, so this is in minutes. It's actually some ugly number, like 3.9 or something. After a year, they line up again. And after I wrote the word year, I was like, wait, which year? And so you use this one for sure. So here's the trick. Just imagine that there was a star at the end of the standard time pointer. That star is the mean sun. And so basically the mean sun scale is a simple linear scale, and there's no need to complicate things. Yeah, so anyway, that's the logic for it. So next time I will clean up the sidereal time scale to actually put numbers on it and have it be slightly less ugly. And then I will add the second date line, which I'm calling the mean sun scale. Not really a great name, but whatever. And I think it lines up exactly at the equinox, but then it ticks linearly for the whole year. And so once I generate that, I'm done the minimum viable product. It will be usable at that point. Now, there are lots of things that would make it less frustrating to use, like labeling these lines with what azimuth and elevation they are. I really, really do want to put in the constellation line art. Like, that's just a must-have for me. I really like that kind of thing. And then I guess I can do a test print at that point. So yeah, I think the next session we'll be able to finish. Yeah, all right.